Pleasure to be here. Thank you very much for the invite. I'm Matt Hatton. I'm one of the founding partners of Transforma Insights. I'm going to share with you today some perspectives on what we see as a bit of a seismic shift. Can you have a bit of a seismic shift? A seismic shift in what's happening in IoT and specifically in the connectivity piece. A little bit about Transforma Insights first. It was founded by myself and a gentleman called Jim Morrish. We're the guys behind Makina Research, which was established in 2011 and rapidly established itself as the #1 go-to analyst firm in IoT. We sold that to Gartner in 2016, and we launched Transforma Insights in November last year. With the new company, we're expanding the IoT footprint a little bit into things like data exchange, artificial intelligence, blockchain, and so forth. The reason for that is it's increasingly difficult to talk about IoT without discussing those other adjacent technologies and areas and how they interact. And I'll talk a little bit more about that later on. What do? We produce reports looking at technical and commercial best practice. We have databases of real-world IoT deployments. We have IoT forecasts, obviously, and oddly for an analyst presentation, I'm not going to be talking about forecasts. Me, I'm an analyst of 25 years standing. Most of that's been focused on IoT and before that M2M and telematics. But I'm a telecoms guy of old. My master's degree was telecoms. I worked as a telecom operator, and a lot of what I used to focus on in my time before IoT was the mobile market. The artistic amongst you will have spotted that this first slide is a picture of fighting Temeraire, a painting that represents a changing of the guard, if you like, a move from the age of sail to the age of steam. And I could have used this at any time probably in the last 10 years, or almost any time in the last 10 years, to talk about transformational changes. But I feel like in the regard of telecoms and IoT, things are changing now more than they might otherwise have been in quite a long time. And this has some significant implications. But it hasn't always been thus. I've been using a term recently called the first IoT winter to describe the last 5 years. Commentators in AI talk about winters. We've had 2 so far, and many think we're on the cusp of a third one. The winter being a period between intense periods of technology evolution. And I want to suggest that we're in our own IoT winter for the last few years. We had a gradual improvement in functionality from the days of SCADA into telematics, when almost everything was a custom build. Then things got really interesting when we moved into a sort of a platformization in the 2010 to 2015 period. Software arrived that removed a whole load of the headache of delivering IoT, and hardware costs fell to the extent that at one point the average cost fell faster than the unit shipments were growing, and so actually the whole market in terms of value contracted, which was a crazy situation, but nevertheless opened up a lot of potential opportunity by declining costs. Connectivity costs also fell. Mobile operators suddenly became quite interested in this space. And we also saw the arrival of a whole bunch of new technologies, particularly in the LPWA space: Sigfox, LoRa, NB-IoT, and so forth. Although NB-IoT was a little later after that. But the point is, lots more tools in that period of 2010 to 2015. And then around 2015, things slowed down a bit. Specifically, the technological development slowed down a bit, and we moved maybe into more of a delivery phase. About a year ago, I was asked to speak at a conference about what had happened in IoT in the last couple of years, and I had to confess that the answer was not a lot, having racked my brains about it. Technologically, a lot of the big hurdles had already been overcome, at least to allow the remote tracking and monitoring applications within IoT to be delivered in an efficient way. Most of the focus historically has been on delivering those, and specifically delivering those low-hanging fruit use cases, rather than thinking about more sophisticated IoT use cases. And I'll come back to talk about this in a moment. Now, this is no criticism particularly. At some point, the technology has to take a breather while the people who are delivering it get to catch up. There is, however, substantial reason to think that now we're accelerating out of this first IoT winter, and telcos, particularly telecoms networks, are central to this. I wrote a couple of reports and a blog post recently about something that I've termed the network new normal, and how the telecoms landscape was changing immeasurably, and how that would have some severe repercussions for how telecommunication services are delivered. Three aspects of this that I want to focus in on, and there are several others, but these for me are the most interesting and important ones. One is around disaggregation and virtualization. What I'm talking about here is the complete separation of the hardware and the software or control elements of the network. It's incorporating ideas like software-defined networking, network function virtualization, and Open RAN. We don't have time to delve into all of those now. And some of them have been around for a while, so not necessarily new, but there definitely seems to be a crystallization of the impact that this is likely to have with all of these things coming at the same time. It's part of a wider trend that we've seen in similar sorts of separation happening in other technology areas, which creates a whole load of innovation. We saw it in personal computing, for instance, and we're bound to see it in telecoms as well. The idea is, as I've coined it, separation, innovation, and explosion. And that permeates a lot of different sectors. Splitting the software and control layer and the hardware, leading to greater innovation. And the reasons for this are pretty obvious. What are the chances that a single company is going to be the most innovative in both software and hardware? Separate them and you allow for best in class. It also generates greater scale in both. I mean, thinking back to PCs, if each manufacturer had their own OS, the fragmentation would be an absolute nightmare for developers. We're also seeing this in other spaces, in robotics, for instance. The companies that made the hardware always used to provide the software associated with it. But there's a new generation of robotics software companies that are delivering the software independent of the hardware and innovating on it. And the same is true of a number of other areas, drones being a pretty obvious one, and one that's pretty close to my heart. It may also be true of IoT devices in the long term, with the likes of AWS's free RTOS and Microsoft's plug-and-play IoT devices, offering some kind of more consistent development environment and potentially maybe more of a unification in the IoT space rather than necessarily a separation, but that might be what's needed in such a fragmented space. Now, based on this idea of separation, innovation, explosion, we'd expect to see the arrival of a whole raft of new innovative software services riding on generic network hardware. More innovation and a potential changing of the guard in who supplies it. We talked to a lot of telcos about what their strategies are, and there's a few interesting elements here. Vodafone, for instance, has made a strategic decision to bring in-house thousands of developers, where that capability previously been shifted out, not literally shifted out, but over time it had moved to the network equipment manufacturers. Microsoft, thinking of this from a different angle, has been on the acquisition trail, buying Affirm Networks, Metaswitch Networks, aimed at providing a set of telecommunication services. Now, ostensibly that might be aimed at the telecoms operators, but actually they have an opportunity there to go direct to their enterprise users. The blurring of the lines between the telecommunications networks, the network operators, software vendors, and the hyperscale cloud providers. Now, this means that the telecoms infrastructure vendors need to adapt to innovate in software. The telcos need to watch their backs as the hyperscalers are starting to impinge on their turf. But it does mean more capability for delivering more interesting services. So they need to think about wargaming next steps, identifying consolidation opportunities and threats. M&A is just around the corner, and it will happen in some really interesting ways. We've seen Reliance Jio selling off part of itself to Amazon and to Facebook recently. That kind of development would have been unthinkable 5 or 10 years ago. 5G. 5G also creates a new network dynamic, unlike anything that we've seen before. We all know the three benefits of 5G: high bandwidth, 100 to 200 megabits per second, which typically most IoT applications don't need. Support for massive IoT, so up to 1 million devices per cell, which also there's not a lot of evidence that there's a huge amount of demand for. And lower latency, realistically in the order of 10 milliseconds. And it's the latency that's the game changer. While a 5x improvement doesn't seem transformational, for instance, it might allow for AR, VR, and a few other IoT applications. But demand for those, again, is unproven. But most importantly, the access network stops being the slow bit. Historically, that has been the case. Historically, the RAN accounted for 2/3 of the latency in the network. In the new dynamic with 5G, the core is 2/3 of the latency. Now, every application gains from these improvements, but applications hosted at the edge get a proportionately bigger gain. This means potentially a shift in architecture, more intelligence at the network edge, for instance, the 5G base station doubling as a mini data center, and less in the cloud, and less on the edge device itself. Why have smart edge devices when latency to a much more cost-effective and scalable processing is available at the network edge just 10 milliseconds away? For mobile operators, this means much more valuable real estate and potentially much more traffic. So rather than processing on the edge device, you process at the edge of the network. The hyperscalers know this, which is why AWS, Microsoft, and so forth are making a play for this for the network edge. And this brings us to edge computing, the third element that I've highlighted. The rise of IoT, robotics, AI, and particularly for real-time data processing, for instance, as we see in autonomous vehicles, has created a lot greater demand for fast response times to allow real-time management of machines or decision-making, or offers the potential for creating that demand. And it's not even necessarily about absolute speeds. In some cases, it's just about being faster than the competition. I'll give an extreme example, which isn't really an IoT example, but it sort of points the finger. High frequency trading doesn't gain particularly from being faster in absolute terms, but gains from being faster than everyone else. And if you were making a decision about which supplier to use, you're probably more likely to pick the one with the lower latency rather than the one with the higher latency. Taken as a whole, these three trends and a few others that I didn't really have time for mean more innovation, new architectures, new vendors, and as I mentioned before, a blurring of the lines between the various players in the value chain. There's also quite a shake-up going on in how connectivity is delivered. 10 years ago, if you'd wanted to connect a device to a wide area network, you pretty much had one option. Add a 2G, probably, modem to it and stick a SIM card in it. You could go almost anywhere in the world, connect to at least one operator. It was pricey, but it was simple. But we started to see more of what I can only term parochialism creeping in the early 2010s. We saw permanent roaming bans in Brazil, India, Turkey, based on either explicit reasons or for local registration requirements or tax obligations. We also saw the commercial equivalents in the likes of the US and Canada, where the operators would refuse permanent roaming. Now, I don't want to suggest that this is improper. Those restrictions on permanent roaming were perfectly reasonable, because putting a device into a market and leaving it there for 10 years was not really within the spirit of roaming agreements. But then we overcame those barriers. EUICC, there's been some discussion of that already this morning, alliances, local breakout, and so forth. That did concentrate a bit more power in the hands of the bigger operators, those that are better able to strike the agreements necessary or to set up the alliances or roll out subscription management or whatever. But it did iron out some of the problems. The pendulum swung back in the direction of the global again. Fast forward 5 years, and we see the pendulum swinging back towards the local. At a basic level, the networks are more fragmented. 2G and 3G, we've seen 2G and 3G switch off, which means that you can never be sure that there's going to be networks available for your 2G or 3G devices. 5G rollout is happening in a patchy way. The availability of narrowband IoT, LTE-M, LoRa, Sigfox, and so forth is not consistent. There is less guarantee across all of these things of a consistent deployment environment now than there was 10 years ago. The tools themselves may be better, but the deployment environment is more diverse. Speaking of narrowband IoT, there's a specific local related issue with that. Even where it's deployed, there's going to be a world of difference in the degree to which it's been optimized and fine-tuned. Battery life here is the critical thing, and the way the network's deployed will have a lot of impact on that. So the fate of the two is much more inextricably linked than would have been the case, say, with 2G. You need to make sure that your in-country network deployment and optimization has been done properly if you're going to be able to deliver narrowband IoT in the right way. And maybe you're not necessarily able to trust other providers in other markets in the same way that you would have been able to do with say, GPRS. 5G has a similar dynamic. Things like network slicing and the support for private networks mean that it becomes less relevant to just drop a random device onto any network and expect it to be to work perfectly. There's no longer an arm's length relationship between the device and the network, and you need to make sure that the network is optimized for what's supposed to be achieving. And everything has become much more specialized, much more localized. The dynamic has changed again. On the plus side, we do seem to have seen some resolution of some of the issues we've seen with regard to the IoT value chain. Back in April, I published a book called The Internet of Things Myth with William Webb, who I think is speaking next week on the second session of this, so he may be able to share some views on the other aspects of the book. But I want to focus on one thing: playing in other people's parts of the value chain. That's one of the areas, one of the challenges that we're holding back to IoT deployments that we talk about. There's a lot of interest in the software and the service provision bits of the value chain, particularly because that's where the margin is. If you think about software, almost everyone, not the telcos to their credit, but quite a lot of other companies want to command the unicorn valuations, the sky high valuations, the 20, 30x revenue that we saw with Jasper and ThingWorks and these types of players. And they do by thinking, okay, I'll pivot to become a software player. Simple? Well, maybe, but there's a massive case of survivorship bias associated with this. Some software companies commanded those valuations, but lots of them didn't and just disappeared. Only a small fraction succeed. And the chance of a pivot working was negligible. So one area where people have tried to play in other parts of the value chain unsuccessfully. Service provision. For telcos, this was the main honey trap, was these end user solutions. They assumed that they could provide vertical services, including consumer offerings, as well as the specialist is. But there's also an element of survival of the fittest in there as well. What was the chance, for instance, that AT&T's connected home offering would be market leading? It's difficult. Typically, most companies struggle to even compete effectively in their own market. And that's not specific to mobile operators. I'm not singling them out particularly. This is relevant across the whole of the IoT value chain. But what are the chances that they'll be good at someone else's bit of the value chain? Limited. And most telcos seem to be getting that message. Does that mean that they can't venture elsewhere in the value chain? Of course not. Through acquisition or the application of some other differentiator, for instance, massive scale, we can. We can't just decide to be an IoT platform provider, for instance, and expect the market to fall into place. You need a differentiator. Vodafone, for instance, bought some companies. Cobra Automotive to play in the automotive space, IoT Next to play in mining, Grand Centrix to address the connected industrial devices market, and a couple of others. Whereas someone like Deutsche Telekom has taken a decision, a new strategic approach to focus instead on mostly the horizontal elements, certainly when we're thinking about the enterprise IoT space. Obviously, that's easier for them to make that decision because they've got strong systems integration play. But generally, what we've seen is a resolution of this issue of trying to play in too many places in the value chain, which we see as a positive development. Because the focus has to be on horizontal capabilities. And in this instance, and what we want to talk about now, is harnessing the next waves of growth. Over the last 6 months or so, we've done a lot of work looking at real-world deployments of IoT. And the fact is that the vast majority is about simple tracking or remote monitoring. These are not about more sophisticated things like integrated supply chain or as-a-service-based business models. Check out our blog if you're interested in this. I've talked about it a lot on there. But the next phase is going to be more about transformation, which would have inevitably involve doing more with data. So the focus for telcos, as we move into that more transformational phase of IoT, is on providing the foundational elements to support that next generation IoT deployment. 2 examples. AI. The natural step for an IoT implementation is to move from monitoring to controlling to automating. AI is what enables the ultimate in automation. I can't go into the intricacies of AI within the few minutes I have left, but it's safe to say it needs a lot of processing, and ideally lots of processing close to the application. 5G and edge computing are relevant here, of course. And then data exchange. The more complex applications naturally involve some complexity of stakeholders. As a side note here, our research found that IoT applications to date were effectively only complex in, at most, one area. For instance, it might be complex in geography, or it might be complex in operations, or it might be complex in stakeholders. If you want an application to involve many different stakeholders, or if you want to monetize it, you need tools to allow you to do that. That's where the data exchange platform comes in. There's a few examples from operators: KPN's Data Services Hub, Deutsche Telekom's Data Intelligence Hub, multi-tenanted platforms which ingest, manage, rate, deliver, and bill for IoT data. Well, actually, not specifically necessarily for IoT data, but really that's where everyone's thinking to use it, because that's where a tremendous amount more of the value is. Here, telcos have a strength. They're located at the edge of the network, and they have oversight of the data flows to allow them to validate and vouch for data authenticity, a strong horizontal opportunity in this space. Recommendations time. As I've discussed, there's some really significant changes happening in the broader telco landscape, and I'm conscious that I've rushed through them quite fast. So if anybody is interested in discussing them further, please do get in touch. But these changes will have a significant impact on how telcos deliver IoT. And everything's in a state of flux, and it's really time to get your horizon scanning in order. Understand what the wider technology environment is doing outside perhaps of the telecoms bubble. The relationship between the network and the device, which is, let's face it, a fundamental for telcos, has changed. It's not about the device on a network, it's now the device and the network. And everything is moving to the edge. And telcos have a really valuable real estate there, and they must be careful not to fritter it away. And as discussed a little earlier, know your place in the value chain, pursue a market where you have a real differentiator, and keep horizontal where you don't. And those horizontal opportunities exist to facilitate AI and data exchange. And a final point, which is a shameless plug for a forthcoming report. We have our CSP IoT benchmarking report coming out soon, which looks at operator strategies in the space. But be aware that the competitive landscape is changing, and as never before, competition is going to come from other directions in this network new normal. And at that point, I think I'm at time, and I will open it up for questions.
Very good timing indeed, Matt. Thank you. Really interesting. So one of the things I'm interested in, and I was thinking about it as well with Kai actually, although we ran out of time. Sorry about the hand of the Baskervilles in the background. Talking about data and how important it is and the possible advantage it gives to telcos. Have we really solved the data problem, as in lots of data in different formats from incompatible sources and all that stuff? I mean, it's a very big, tough problem to solve, but we've been at it for maybe a decade as telcos.
Mm-hmm. Yeah, and it's particularly challenging with IoT because you have such diversity of formats and so forth. I don't think there's a simple answer, other than that you need to be able to cope with it. There are tools available for managing and organizing data in all sorts of formats. It's just it's this sort of next step of data analytics that historically was always focused on tabulated data, and we've moved to one where it needs to be much faster to react because you're talking about IoT data. It needs to be able to cope with video and audio and all sorts of other forms of data. So it's more complex, but I think we're getting there. Are tools becoming available?
So, in other words, it's something we're making progress on, but we haven't really kind of figured it yet. And I mean, to me, that's a really an interesting reason why we're going to see more and more discussion about AI and IoT. Would you agree with that, Matt?
To an extent, because you can apply AI to almost any type of data feed. So video feeds is an obvious one to identify. Okay, is somebody walking into a public place and putting down a bag and walking off? That kind of analytics is absolutely critical, and there are plenty of suppliers able to do that. There's a plethora of different service providers in that kind of space, software options.
Okay, well, we've got to go because we have Dr. John, who's the Chief Scientist in Future Business Technology at BT, waiting for us. But I would maybe suggest to you, Matt, that one of the problems is the plethora of companies, and it's jolly hard to figure out who's doing what and who's just put go faster stripes on something.
Fair point. Fair point.
Thank you so much. Really interesting.
Thanks, Lainey. Take care.